Hi everybody, Mr. Salona here. Today we're going to be doing the Impulse and Momentum Lab, and our job is to look at how impulse and change in momentum are related to each other, and also look at how using different materials can change the impulse or force and time acting on an object. So what we're going to need for this experiment is we're going to need the new vernier GoDirect sensor carts. We're going to need a block of masses. We're going to need the masses for the actual cart. We're going to need a scale. We're going to need the hoop bumper attachment for the cart. We're going to need the rubber bumper attachment for the cart. And we're going to need a string that also has a piece of rubber band attached. This will already be set up for you for the lab, like so. Okay, so first thing we're going to want to do is to take the mass of the cart with and without the extra masses attached. So if I put the cart on the scale, I'm getting 290 grams. And if I place the masses on top, those four masses all combined give me 500 grams. Okay, so I have 500 grams and 290 grams for a total of 790. I'm going to be using the cart both full and empty, so you want to make sure that you know both of those masses, and you're going to convert those to kilograms. So the empty cart would be 0.290 kilograms for me, and the cart with the masses in it would be 0.790 kilograms. Okay, so next, what we're going to do is we're going to attach the cart to the computer. This is Bluetooth, so what we're going to do is turn it on, and a little red light will light up on the cart, and you're going to open up graphical analysis on your Chromebook and go to sensor data collection. Once that opens up, it's going to ask you to connect, and if your cart is on and close by, it'll say discovered wireless devices, and then it'll list some Bluetooth devices. Now here's the thing you have to be careful of. Right now I'm doing this video by myself. If you're working in the lab, everybody's going to have their carts turned on. You have to make sure that you pair your cart with your Chromebook. So what you need to do is make sure to check the ID number and make sure that that matches the one that's showing up on the screen. So mine's ends in 200464. I see that that's the correct one, so I'm going to click on that. And then I'm going to go, once it loads up, to sensor channels, and I want to show both position and force. So we want to have both of those checked, and click done. When the window comes up, I'm actually going to change this to just 2 graphs. So I can click this window up here and say 2 graphs. And I want a graph of force, so we're good on that. And then I want a graph of velocity. So I'm going to click on this and change this to velocity, turn position off. I'm also going to zero out the force sensor. So down at the bottom right, I click on this and just click 0 for the force. And we're good to go. All right, so then next, I'm going to attach the hook attachment to the cart. So this is just a screw that goes in. So you screw it into the end of the cart and set it up like that. So I already had it mostly in. Then I'm going to take my string. One end has a big loop on it with a zip tie. We're going to put that over the pole, and we're all set there. And then we're going to attach the other end. There's another zip tie and also a rubber band. We're going to start with the zip tie end because we're going to use just the string and neglect the rubber band. So we're going to attach the loop here, and then the cart is ready to go. And what I'm going to do is I'm going to click collect and then give the cart a push. So you'll have partners to do this and help you out. But what I'm going to do is hit collect and then give the cart a push, like so. Okay, so what you'll notice here is that we have a graph here of velocity, and it starts out 0 for a while, and then it became negative, and then positive. And it's negative because you're moving away from the pole at first and then back towards it. And towards the pole is the positive direction. Okay, so we start out with a negative velocity and end up with a positive velocity. We also have this force versus time curve here. That's when the string got originally tight. So we had no force at first, and then a spike all of a sudden, and then the cord got slack again, or the string got slack again. What I need to collect from this is the initial and the final velocity and the force, the impulse from the force graph and the time. So with my mouse, what I'm going to do is come over here and I'm going to highlight right before the impulse happens. So this flat portion here is what I really want. I'm going to click that and I can see that that velocity is negative 0.879 meters per second. Okay, and what I'm going to do is I'm going to record that where it says initial velocity. I'm going to go negative 0.879, and then I'm going to go back to my vernier, and I'm going to find the final velocity. It's right after that happened, and I can see that that's 0.441 meters per second. So you're looking for these more or less flat portions of the graph. So 0.441, I'm going to put that in for V final. Just like that. I'm also going to need to collect the impulse. I clicked on the wrong window there. Collect the impulse. So what I do is I want to highlight, you got to be careful about this, but you want to highlight under the graph the portion of the graph that is the spike. So I'm going to click on View Integral, and I look at this section here, and I can see that the area is 0.121 Newton seconds. I'm going to record that as well, 0.121 Newton seconds. So I'm going to put that in where it says impulse. And the last thing I need is the time over which that happened. So I want to look from here 2.38 seconds to the other end of that, which that's too far, to 2.52 seconds. So I can subtract those two values and get 0.14 seconds. So the impulse interval was 0.14 seconds. So the time, 0.14 seconds. And that's the data that I need for that step. The rest of these cells are things that we can calculate later on. I'm going to repeat the same process, but instead I'm going to load the cart up with mass. So I'm going to put the 4 masses in the cart and repeat all the same steps. So I'll do that, collect the data, and that will go in those 4 places. Then what I'll do is I'll switch it out, and instead of using just string, I'm going to use this rubber band as well. So I'm going to attach the rubber band end to the cart. And it doesn't matter if you do the loaded cart first or the empty cart first, but you're going to end up doing both. So you'll hit collect again, you'll give the cart a push with the rubber band attachment, and it'll give you the graphs just like before. We'll collect the same 4 pieces of information. And then one more time, either with the loaded cart or the unloaded cart. So a total of 4 trials. After that, we're going to change gears a little bit. So what I'm going to do is I'm going to keep the cart loaded, but I'm going to disconnect the string and rubber band. And I'm going to take this hook attachment off. And instead, I'm going to put on this rubber bumper. Because now what we're going to do is we're going to crash the cart into an obstacle. So we're going to take it like this. And we're going to turn the cart around. And we're going to take this mass block just to use as our obstacle. And I'll come back to vernier. This time I'm going to push the cart towards the obstacle and just let it crash into it. So here, press collect, and just let it crash in. Okay, so you'll notice in this one that the curve is actually showing a negative force because now the force is working in that opposite direction. Okay, so we can still get the area from that graph just like before. We can still get the time just like we did before. And you'll notice your velocity started out positive and then dropped basically to zero because it hit the obstacle and essentially stopped. There was a little bit of a backwards recoil at first, and then it stopped completely after that. So again, we get the same 4 pieces of information. We need the area of this curve, we need the time interval, we need the initial velocity, and the final velocity. And you want to get the final velocity right after the impulse. So it's not quite zero. If I click on, here, it's very small, negative 0.031 meters per second. Okay. For the final trial, do the exact same thing, except we're going to take off the rubber bumper. And instead, we're going to attach this hoop bumper. We screw this in just like the rubber bumper. Make sure you put it in straight, not like I'm doing right now. There it goes. Okay. And then one more time, we're going to run this into the obstacle. So I have my hoop bumper set up. I'm going to press collect, give the card a push, bounces off, and comes back. And you can see this one a lot more obviously has this spike for the force and time, and it has this initial velocity here that's positive. This one did bounce backwards afterwards, so we have a negative final velocity. So we'll get the initial velocity, the final velocity, the impulse from the area, and the time interval over which it happens. Once we have all that data, then we'll be able to compute things like the change in momentum using the initial velocity and the final velocity and knowing the mass of the cart. We'll be able to calculate the force because we know the impulse from the area and we know the time interval over which that force occurred. Okay, so we can figure out how much force. And then we can compare the impulse to the change in momentum. We can compare the maximum amount of forces and the average force, and we can look at what the differences were in all of those cases and try to analyze the data from there.